Lesson 9b, Net Work. For work to be done, the force acting on an object must be in line with motion, or a component of it must be in line with motion. Inline meaning in either direction in one plane. So in this example, the force applied is entirely in line with the motion, and in the same direction. So the force is doing a lot of work. In this example, the force is not entirely in line, although a component of its force is in line with the horizontal, meaning a smaller component of the applied force is doing work on the object. And this applied force has an even smaller component in the horizontal, so there is even less work done by the force to displace the object in the horizontal. And finally, this force does not have any component in the horizontal, which is in the direction of displacement. So this force has done no work to move the object to the right. There must be some other force acting on it to displace it to the right, even though it's not seen, or it is traveling at uniform motion to the right with no net forces acting on it. So in this picture, the vertical force applied to the buckets to keep them from falling to the ground are not in the horizontal, nor is there any components in the horizontal. So they are not doing any work to move the buckets to the right. There are other forces, though, that are not seen, that are acting on the buckets, that would account for the work done to move the buckets to the right. Net work is the sum of all work done to and by an object. We can calculate net work similarly to how we calculate net forces. Let's use our last example. You have a block on a table. You assume that the applied force on the block is 25 newtons of force, and there is 35 newtons of friction force acting on the block. The block moves to the right in the direction of the applied force. It displaces 10 meters to the right. Using component method, we see that net work equals the sum of all work on the block, which is work applied plus work friction. That's 250 plus negative 350. Net work is minus 100 Newton meters, or equivalently minus 100 joules. We can calculate net work by using net forces. Fnet is the sum of forces, which is applied force minus friction force. Fnet is 25 plus minus 35. Fnet is minus 10 newtons. Net work then is Fnet times displacement. Net work is negative 10 times 10. Net work is negative 100 Newton meters, or equally negative 100 joules.